We're just about ready to get started on topic 3 of chapter 2. And here I've put up a few little points to go over as we continue our work on solving linear equations. By the way, linear indicates that the variables are only to the first power. If they were greater than the first power, x to the second, they would not be linear. So the first thing we should do when we see an equation is look to see if there are fractions, the traditional fractions or decimal fractions, and we should get rid of those by multiplying each term by the lowest common denominator. We did, I think, a few in the previous lesson. Then we look to get rid of grouping symbols, whether they're parentheses, brackets, division bars, absolute value. We don't do any of that right here, but in later chapters. Then we want to combine like terms. Then we're going to do something that we call transpose, and that is using the additive inverse to get something from one side to the other side. And I'll go over that with you now. Then we want to isolate so it's just an x. And we're usually going to do that by dividing by the numerical coefficient. So the x becomes a 1x. Every once in a while we'll use the reciprocal. Again, we illustrated that in the previous section. And then if you're doing a test, you'll definitely want to check it if it's, not too difficult. Okay, well, let's go on and we'll be illustrating some of these things as we go on. Now, for this first one, we see there are no fractions, but there is a grouping symbol. So let's put it up here. We get 6a. Now there's a negative sign in front of a parenthesis. So this indicates we just reverse all the signs. A negative 5a, and this becomes a positive 1. And this equals 4. So we've just gotten rid of the grouping symbol. Now we group like terms, and this becomes an a. And now I'm going to introduce what we call transpose. Well, transpose simply means taking a term from one side of the equation and bringing it over to the other side. Now, when it crosses the equal sign, the sign of the term changes. So on this side it was a positive, now it will become a negative. Now it's the same as, what's the additive inverse of this? A negative 1. So you subtract a negative 1, subtract a negative 1. That's what transposing is. This is sort of the shortcut, and this gives you a 3. Now in letter B, again, there's no fractions. We don't get down to the fractions until here, but we have to get rid of the parentheses. So this is going to be, let's just do it, 12b minus 4 equals 16. All right, we're going to transpose the 4. On this side, it becomes a positive 4. So again, we're taking it from this side to the other side. So this gives us 12b equals 20. And now we have to isolate the letter by dividing by the numerical coefficient. So this can reduce to, let's see, we can take a 4 out of there, and that gives us a 5. And a 4 out of there gives us a 3. So for letter B, B is 5/3. Now for this one, we have 4z. We're going to get rid of the parentheses. 8 times 2z is 16z. 8 times 9 is 72. And we want to keep our variable positive. So I'm going to transpose this. That will give me a 12c. And I'm going to transpose that. Just change its sign. And that gives me a negative 72. And I divide both sides by 12. And I get on this side a positive z equals a negative 6. Now, because of limited space, I'm not setting this up really neatly, but notice I'm trying to keep the steps in a logical way, the equal signs somewhat underneath each other. That's an important trait for these. All right, let's go on to letter D. I'll go over here. So we get 2x plus 16 equals 3x minus 15. 3x minus 15. Okay. Want to keep the x's positive. So I'm going to transpose this. It becomes a negative 2x. So this just becomes an x then. And this negative goes to this side and becomes a positive. And when we add them together, we get x equals 31. And let's do this one here. So we get 6a minus 9. 3 times a negative 3, we're watching the signs. And we get 5a plus 20. And again, you can still use that old method of subtracting 5 here and 5a here, but transposing is the shortcut. So this just becomes an a. And you do that part mentally. And here your negative 9 becomes a positive 9 over here. So this gives you that. A equals 29. All right, letter F. So 4 times 12 is 48. C. Negative 2 times 12 is a negative 24. Equals 3c minus 4. Now again, we're going to transpose the positive 3. On this side it becomes a negative 3. So this is 45c. And this side, a negative 24 on this side becomes a positive 24. And this gives us a 20. Just showing that we're transposing. Now you could use the other methods still, but this is sort of the shortcut. Now to isolate the 45, we divide by it. The numerical coefficient. Now here, this becomes C. And we can take a 5 out of there. And a 5 out of there. And C equals 4/9. So I'm going to raise it up. We'll lose all of this, but keep in mind, you might put this somewhere in your notes. This is the protocol, the series of steps that you do when you go to solve linear equations. And you might say, we didn't do any of the checks. Well, we did by looking down to see if we got the right answer. Okay, let's go on. So as we go on to number 2, we see that now there are fractions. So let's look at our strategy. Well, we said that if we multiply each term, there's one term, another term, a third term, by the common denominator, which is 6, we're keeping this equation equal, but making it larger by multiplying everything by 6. But in so doing, we get rid of the fractions, which is a good technique. So let's put that here. That'll be y. Now, -4 times 6 is a -24 equals 6. So by multiplying every term, I've made the equation larger, but in the process, gotten rid of the fractions. So we just transpose that. On this side, it's going to become a positive 24, which gives us a 30. And then we don't have to worry about fractions. Now, for letter B, I'm going to show you another technique where we put a bracket around the whole equation. And again, look for the least common denominator, which is 8. And we will multiply then each term by 8. So here it cancels. We get a 1. Here we get a 2. So this will give us a 2x. Here the 8 will cancel with the 8. That'll give you the 8 just goes away. This gives you a -3x. And then your 8, again, I shouldn't have put the cancel mark through it. We have to use it each time. And that'll give me a 40. So here I get a -x equals 40. So a positive x, as we said, we could just switch the signs, is a -40. Because if we divided each side by a -1, this would be our results. The shortcut was this. All right, here we're going back to the old method because you'll see why in a moment. What's our lowest common denominator? A 4. So we're going to multiply this term, and that division bar is a grouping symbol, by a 4. We're going to multiply this one by a 4, and this one by a 4. Now here, I like this way because we can just cancel it out. We don't have to use it again because we've written it this way. So this becomes a -6x plus 5. Now this is going to be plus 4 equals, again this cancels out, and that's a -5x. We don't have fractions anymore. Now we're going to transpose to keep our x's positive. So here it's a -5, here's a -6, so bringing this over to this side, it becomes a positive 6x, which just leaves me with an x, and this leaves me with a 9. X equals 9. Just look how difficult this could have been, but by multiplying every term by the lowest common denominator, getting rid of the fractions, it became rather easy. Okay, going on to our next equation, and notice it has lots of decimals. Well, first let's just identify the terms. This is one term. Now again, this is one term, and this is one term. So to get rid of our decimals, I'm going to multiply everything by 100, because this has 2 decimals, this has 2 decimals, and that would be multiplying this by 100, multiplying this by 100. Now what I had to do here is add 2 decimal places, so that when I multiply it by 100, it looks like that. So what do I have then? Let me write it up here. I have 5x, then I have plus 6, this is a 6 times x, so I'll go 6x, and then 6 times this, and I'm using my calculator. 6 times a -1500 gives me a -9000, and it equals this. So this is going to add up to 11x here. I'm going to add 900 to the other side, and I get 66,000, and I'm going to divide both sides now by 11, and that's going to be 6,000, and that should be our answer. Okay, so the technique here is to get rid of those decimals. Again, this is just one term. That may be a little confusing. All right, let's go on to letter E. And you might say, well, what strategy do we use? Well, again, if we identify the terms, this is one term, this is one term, this is one term, and I see a decimal to the 10th place, so I'm going to multiply everything by 10, just by moving the decimal place over 1 in each term. So this then becomes 4x plus 28. Now watch, this is a -1, so a -3x, -6 equals 8. Now we're going to combine like terms. We have a 4x and a -3x, which just leaves me with x. We have a positive 28 and a -6, leaves me with a positive 22, and I have 8. So again, I'm little by little whittling this down to isolate the variable. So I get x equals, as I subtract 8 from both sides, or I should say I'm transposing the 22, which becomes a -22 on that side, gives me a -14. So it could have been a little tedious trying to keep track of all the decimal points, but by multiplying each term by 10, we're able to do that. Now, every once in a while we do make an error, and I did check my work here, and I said, uh-oh. Notice that when I copied this, you see that little negative sign right there? I forgot to put it there. Oh. So that's a -8, and a -22 gives me a -30. So again, it never hurts to check your work and copy it correctly. All right, we learn by our errors as well. Okay, going on now to the last few examples. Every once in a while you're going to run into something like this. It's going to say x plus 2 equals x plus 3. Now, does it look like an equation? Yes, because it has an equal sign. But notice what happens if we subtract x's from both sides. We then get 2 equals 3. Is that a true statement? And the answer is no, that's not true. So even though it looks like an equation, it's not really, because there will never be a value of x that will make this statement true. So there is no solution for something like that. Now, how about if you had something like this? X plus 2 equals x plus 2. And you might say, well, yeah, it's exactly the same thing on both sides. So if you subtracted 2 here from both, you would get x equals x. Now, is that true? Yes. But what is x? Well, here we say x is any real number. So there's an infinite number of solutions. Whatever you put for this x, that's what this x would be. And it is true. Okay? And that's what they're saying here. Whether it's an identity, because that's what this is, it's an identity, or whether it's an equation with no solution, which is what we have here. Okay? That's the background of this. So let's go on and do these. Now, as you look at it right away, do they look like they're the same? Not right away, but look at this. 6z plus 42 equals 6z plus 42. Oh, this is an identity. So, all real numbers. Now, this one looks a little tricky because, let's see what comes out of it. So we're going to take our 3 and our negative 1, and I'm going to put 12x plus 2 here, just grouping like terms. And here I'm going to get 12x minus 1. Now, when I subtract out the 12x's, I get 2 equals a negative 1. Is that true? No. So for this one, there is no solution. Now notice in the beginning, it didn't quite look like that. This one was a little easy because all you had to do is clear the parenthesis. But you have to do that to make your determination. Now here we're going to multiply everything by 6. Each term. 3 cancels out. We get a 2 here. So 2x minus 18. This cancels out. And we get 2x plus 6. Now again, the 2x's are going to cancel out. And I get a negative 18 equals 6. Is that a true statement? No. So again, for this one, no solution. Okay, we're moving along and we'll be starting word problems shortly.